Good day, great minds, and welcome to the first edition of our Math Marathon class. Today, we'll be starting with the basic definitions in mathematics. Though it's necessary that we start there. I know it's common, it's something common, what everyone knows. But it's still okay that we start there because I believe that there are maybe the younger ones that are not too familiar with it. So let's just start from there. Basic definitions. Okay, the first one is square of a number. Square of a number. And this is the value. This is the value obtained when a number multiplies itself twice. Example, when you say square of 2, square of 2 can also be written as 2 square, which is just 2 times 2, that is 4. You can also say square of 3, that is something as 3 square, and that is 3 times 3, which is equal to 9. Now the second definition is cube of a number. Cube of a number. And this is the result. This is the result of multiplying a number by itself 3 times. Example, when you say cube of 3, which is also the same thing as 3 raised to the power 3, which is also the same thing as 3 times 3 times 3, and which is 27. Or you can say cube of 4, which is the same thing 4 raised to the power 3, which is the same thing as 4 times 4 times 4, and which is 64. Then, okay, the third one is square root of a number, which can be denoted with this sign, square root sign. And it says, this is the value which, when multiplied by itself 2 times gives the original number. Example. When we say square root of square root of 4, that is equal to 2, as 2 times 2 give us 4. Square root of 4 is 2. Since from the definition we said it's a value, which one? So it's a value which this is a value which when multiplied by itself, which when multiplied by itself 2 times gives the original number. This is the original number, which is 4. Then when you take square root of 4, it gives 2. If you multiply 2, it gives you this, and it gives you 4. So we say square root of 9 is 3, as 3 times 3 equals 9. And another one is cube root of a number. Which can be denoted with cube roots. This is ready. This is the value. This is the value which when multiplied by itself 3 times gives the original number. Example. When we say cube root of 8 equal to what? 2, as 2 times 2 times 2 equals 8. From the definition, the value is the value which when you multiply it 3 times gives you the original number, which is 8. Then cube root of 27, which is equal to 3, as 3 times 3 times 3 is equal to what? 27. Now another one is reciprocal of a number. And this is just the inverse. This is the inverse of a number. Or you can say it is the value when a number is turned upside down. Example. Reciprocal of 2 is 1 over 2. Reciprocal of 2 over 3 is 3 over 2. Meanwhile, there's a way to get this reciprocal. Reciprocal just like they said is the inverse. So if you are given something like this, 2 over 3 to get the inverse, and they said you should show working, just you do 1 over 2 over 3. And this is the same thing as 1 divided by 2 over 3. And this is the same thing as 1 multiplied by 3 over 2. I want you to notice what happened here. 1 divided by 2 over 3. And the moment we change that division sign to multiplication, we inverse the other number, which is 2 over 2. And that is how it's done in mathematics. So if you multiply, this one is still 1 over 1. So whether you leave it this way, so 1 times 3 is 3, then 1 times 2 is 2. So that is how we got 3 over 2. So in case you're asked to show working, which we will do, that is reciprocal. So another one is reciprocal factors. Factors of a number. Factors of a number. Factors of a number. Okay. These are the possible multiples. That can be combined. Combined to produce a given number. There are possible multiples that can be combined to produce a given number. For instance, if you're asked to find example now, find the factors of 12 and this is 12. What can go in 12? 2, and we get 6. What can go in 6? 2, and we get 3, and then what can go is 3, we get 1. Therefore, factors of 12 is equal to 2 times 2 times 3. I hope it's clear. These are possible multiples. These are the possible multiples that can be combined to produce a given factor. And how to get the multiples is divide the number you are given using starting from the smallest number that can divide it aside 1. You don't use 1. So the smallest number that can divide 12 is 2. Once you are done with 2, what I mean by done with 2 is when 2 can no longer go in the number that follows, then you now use 3. So you jump to 3. If you check 3 cannot go, you try 4, and from there, then go on. So from here we get that the factors of 12 are 2 times 2 times 3. Another one is perfect square. Another one is perfect square. Perfect square. Perfect square. This is a number. This is a number that can be expressed in even powers. Even powers of a smaller number. Or you can say, or 2, even powers of 2. So either a smaller number or 2. Then, example of a perfect square. 4 is a perfect square. 4 is a perfect square because 4 can be expressed as 2 raised to power 2. Then 9 is also a perfect square. 9 can be expressed as 3 raised to power 2. Also, 15. Okay, no, 15 is not. 16 is a perfect square. 16 is a perfect square because 16 is the same thing as 4 to the power 2. And then so on and so forth. Another one is a perfect cube. Perfect cube. This is a number that can be expressed in odd powers of 3. This is a number that can be expressed in odd powers of 3. Odd powers of 3. Example: 8 is a perfect cube. Because 8 can be expressed as 2 raised to power 3. Then another definition you can give to this, either perfect square or perfect cube. Perfect square, you can say, is a number that has whole number square roots. That means once you take the square root of that number, it has the whole number. The value is whole number. The same thing with this one. This is can also be explained. Can also be called a number that has whole number cube root. That is when you take the cube root of this 8, it gives you a whole number. Which is when you take the cube root of this, it gives you 2. So it's either it is this number that can be expressed in odd powers of 3 or any number that has whole number cube root. So this is it. And then another one is 27 is also a perfect cube because it is the same thing as 3 raised to power 3. 64 is also a perfect cube because it's 4 raised to power 3, and then so on and so forth. So another one is so all these things, all this campaign, if you want to copy, if you can just pause the video and copy it. Of course, you can rewatch. I'm sorry, we have a limited board. So another one is prime numbers. Prime numbers. Prime numbers. These are numbers that are divisible only by 1 and itself. Example of it. Now this is saying all this one is saying is okay. Example. This one says prime numbers. They are those numbers that only 1 can divide them. Only 1 and themselves can divide them. For instance, example, 2 is a prime number because it's only 2 and 1 can divide 2. 3 is a prime number. Only 3 and 1 can divide 3. 5 is a prime number. 7 is a prime number. 11 is a prime number. Of course, 8, 9, 10 is not a prime number. And then 13 is a prime number. If you go further, 17, and then so on and so forth. All these numbers can only be divisible by themselves and 1. So that's why they are called prime numbers. Then when you talk about prime factors now, prime factors, these are factors of a number. These are factors of a number that are prime, or you can say they are the factors of a number, the factors of a number that are only divisible, that are divisible by themselves, by one and themselves, by one and themselves. Okay, let's take for example now. Example, assume I asked to find I'm just managing the board. No, this example would have been on the next line. Find the prime factors of let me just say 24. I pray this thing enters here. Find the prime factors of 24. And this is it. This is 24. And what can go 2 in 24 is 12. 2 in 12 is 6. 2 in 6 is 3. 3 and 3 is 1. Therefore, 24 equals 2 times 2 times 2 times 3. And then prime factors of 24 now. Prime factors of 24 is equal to 2 and 3. Remember, we say prime factors are the factors of a number that are prime. So out of all these numbers now, we only have 2 and 3, and 2 and 3 are prime. So that's 2 and 3 are the prime factors of 24. Okay, this is it for basic terms for now. Maybe if we get to other ones, we can now give maybe there's any explanation, you can give the explanation before we go into that topic proper.